Welcome, everyone. I'm excited to kick off our presentation today with the topic Comparing Quantities. This is the first slide, so I want to warmly welcome you all and introduce what we'll be exploring. The title of our presentation is Comparing Quantities, and we'll also have a subtitle that highlights the key focus. Over the next few slides, we'll look at different ways to compare quantities, learn some useful techniques, and understand their applications. But for now, let's get started and enjoy the journey into understanding how to compare different amounts effectively. Let's take a look at the contents of today's session. We will cover a range of important topics starting with ratios, which are fundamental in comparing quantities. Next, we'll explore percentages, including how parts always add up to give a whole, and what to do if the total isn't exactly 100%. We'll see how to convert ratios into percentages and vice versa, which is very useful in many real-life situations. We'll also discuss proportions and the unitary method, helping us understand how to find one part when others are known. Moving forward, we'll examine converting decimals to percentages and percentages back to how many. That's key for understanding parts of a whole. Another important area is the use of percentages in various contexts, such as calculating profit or loss, and understanding increases or decreases as percentages, which is essential in business and finance. We'll then look into specific calculations like finding selling price when cost price and profit or loss percentage are given, and vice versa. There's also a focus on cost price and selling price relationships, including simple interest over different time periods, like 3 years. Finally, we'll wrap up with concepts involving profit or loss percentages, and some fun with estimation techniques. All these topics connect to give us a comprehensive understanding of how to work with ratios, percentages, and related calculations in practical scenarios. Let's take a closer look at ratios and understand what they really mean. A ratio is essentially a way to compare two quantities. Now, it's important to remember that these quantities need to have the same units. Otherwise, the comparison doesn't make sense. When we write a ratio, we use the symbol, which is read as 2. For example, if we have 3 apples and 4 oranges, we could say the ratio of apples to oranges is 3:4. You can also think of a ratio as a fraction, like 3/4 in this case. This fractional form helps us see the relationship between the two quantities more clearly. Understanding ratios is fundamental because they help us compare and analyze different parts of a whole, which ties into the overall theme of understanding relationships and proportions in data. So remember, the key points are that ratios compare two quantities of the same units, are written with a, and can be expressed as fractions for easier analysis. Today, we're talking about equivalent ratios. Think of them like equivalent fractions. They represent the same relationship or proportion, just expressed differently. To find an equivalent ratio, we need to write it as a fraction. This makes it easier to compare and understand. The key idea here is that to get an equivalent ratio, we multiply or divide both the numerator and the denominator by the same number. This ensures the ratio stays the same, preserving its value. Understanding equivalent ratios is important because it helps us recognize proportional relationships in different contexts, which is a big part of mastering ratios and proportions overall. Now, let's talk about proportion. Proportion is all about showing the relationship between two ratios. Essentially, it helps us understand when these ratios are in balance or equality. When two ratios are in proportion, it means they are equal. This concept is fundamental because it allows us to compare different quantities and see if they maintain a consistent relationship. Throughout this presentation, we'll see how proportion plays a key role in solving problems and understanding relationships in various contexts. So, keeping this idea of equality in mind will help us grasp more complex concepts as we progress. Let's take a closer look at the unitary method. This method is all about finding the value of a single unit first, and then using that to determine the value of the required number of units. Essentially, it helps us simplify complex problems by breaking them down into manageable parts. The key idea here is to determine the cost or value of just one unit, whether it's price, distance, or any other measure. Once we know that, We can easily find out the total for any number of units by multiplying. This approach is very useful because it makes calculations straightforward and helps us understand the relationship between different quantities. Throughout this presentation, you'll see how the unitary method connects to many real-world situations, making problem-solving more intuitive and efficient. Let's talk about the percentage now. Percentages are another useful way to make comparisons. When we deal with ratios, we often need to ensure that the denominators are the same so we can compare them directly. But with percentages, it's a bit simpler. We can compare different quantities directly by calculating what percentage each one represents of the total. This makes it easier to see the relative size or proportion of different parts. So, in essence, percentages allow us to compare things more straightforwardly without having to adjust the ratios, which helps us understand data more clearly and efficiently. Now, let's look at what happens when the total number isn't exactly 100. If the denominator, which is the total quantity we're working with, isn't 100, then we need to do a little adjustment. Essentially, to find the percentage accurately, we have to make the denominator into 100. This means we're scaling our numbers so that the total becomes 100, allowing us to easily compare parts to the whole. It's a crucial concept because percentages are all about understanding parts of 100. Without this adjustment, our percentages wouldn't accurately reflect the proportions. So, whenever we encounter a total that isn't already 100, remember we just have to normalize it to 100 before calculating the percentage. This step ensures our data remains consistent and meaningful within the context of percentages. Now, let's talk about converting fractions to percentages. Fractions often have different denominators, which can make understanding them a bit tricky. To turn these fractions into percentages, we simply multiply the fraction by 100%. This process helps us see the part of a whole more clearly, especially when comparing data or making decisions. Remember, the key is to always multiply by 100% after simplifying the fraction if needed. This step connects to our overall goal of making data more understandable and accessible. By mastering this conversion, you'll be better equipped to interpret and communicate numerical information effectively. Now, let's talk about converting decimals to percentages. The key idea here is that to do this conversion, we first need to think about the decimal as a fraction. Once we have that fraction, the next step is to multiply it by 100%. This process effectively shifts the decimal point 2 places to the right, giving us the percentage. Remember, this step is crucial because percentages are just a way of expressing parts of 100, so converting a decimal into a percentage makes it easier to interpret and compare. This concept ties into the overall theme of understanding different ways to express numerical values, which is fundamental in many real-world applications. So, mastering this conversion helps us communicate numbers more clearly and effectively. Let's talk about how parts always add up to give a whole. When we know one part of a whole, we can actually find the other part because all the parts together make up the entire thing. Remember, this whole is like 100% or the complete picture. So, understanding even just a piece of it helps us figure out what's missing. This idea is really important because it shows us how parts relate to the whole, which is a key concept in understanding proportions and how things fit together. Whether you're working with data, recipes, or any kind of problem, knowing one part can help you understand the entire picture. Now, let's have some fun with estimation. As we've seen, using percentages allows us to approximate parts of an area quickly and effectively. For example, here we're looking at a pizza divided into 2 halves. Each half represents 50% of the whole pizza. This simple example helps us understand how percentages can make it easier to estimate and compare different parts of a whole. Remember, the key is that percentages give us a clear, proportional way to understand portions without needing exact measurements every time. This concept ties directly into our overall theme of developing practical estimation skills, which are useful in everyday situations and more complex data analysis alike. Now, let's discuss how to interpret percentages in real life. When we talk about percentages, it's not just a number. It's a way to understand proportions and make sense of data. For example, if I tell you that Seema is spending 20% of her income, what does that really mean? It means she's spending 20 rupees out of every 100 rupees she earns. So, in practical terms, if her income is 125 rupees, then 20% of that would be 25 rupees. Recognizing what these percentages represent helps us make informed financial decisions and better understand the information presented. It's a key skill that connects numbers to everyday life, making data more meaningful and easier to interpret. All right, let's look at an example to understand how to convert percentages into actual numbers. Suppose we have a situation where 20% of students in a class of 45 students get a distinction. The question is, how many students actually got the distinction? To find out, we take that percentage, 20%, and convert it into a decimal by dividing by 100. So 20 divided by 100 gives us 0.2. Then, we multiply this decimal by the total number of students, which is 45. So the calculation is 0.2 times 45, and that equals 9. This means that 9 students out of 45 received a distinction. The key point here is that converting a percentage to a number involves 2 steps. First, turning the percentage into a decimal, and then multiplying by the total number. This method is really useful because it helps us understand the actual count behind percentages, which is often more meaningful in real-world situations. And remember, this connects to the overall theme of our presentation: understanding data better by translating percentages into concrete numbers. Now, let's talk about ratios to percentages. Converting ratios into percentages is an essential skill because it helps us achieve greater accuracy, especially when dealing with mixtures of different elements or calculating percentage scores on tests. When you're given parts of a quantity in the form of ratios, understanding how to convert them into percentages makes the data much easier to interpret and compare. This conversion process is quite useful because it allows us to express ratios in a more familiar and straightforward way: percentages. Whether you're working in chemistry, statistics, or everyday scenarios, being comfortable with this conversion bridges the gap between different ways of representing data. In essence, mastering ratio to percentage conversion enhances our ability to analyze and interpret information more effectively, which ties back to our overall goal of gaining clarity and precision in quantitative reasoning. Now, let's talk about increasing or decreasing as a percent. Sometimes, we need to figure out how much a quantity has grown or shrunk in percentage terms. For example, imagine the population of a city rising over a decade, or maybe sales dropping in a certain quarter. These are common situations where understanding the percentage change helps us see the scale of the difference more clearly. It's a useful way to compare different data points, especially when the numbers are large or vary significantly. Keep in mind, the key idea here is to measure the change relative to the original amount, which gives us a much clearer picture of the growth or decline. This concept ties into our overall theme of understanding and analyzing data effectively. Now let's talk about cost price and selling price. The cost price, or CP, is simply the price at which you buy a product. It's what you pay to acquire it. On the other hand, the selling price, or SB, is the price at which you sell that product to your customers. These two figures are crucial because they help us determine whether a sale is profitable or not. If the selling price is higher than the cost price, then you're making a profit. But if it's lower, then you're incurring a loss. Understanding these concepts is essential for making smart business decisions and ensuring your sales are profitable. They form the foundation of pricing strategies and help us evaluate our overall performance in the market. Let's talk about profit or loss percentage. This is a really useful way to understand how well a business is doing, because it puts the profit or loss into perspective relative to the cost. The key point here is that we always calculate this percentage based on the cost price, not the selling price. So, for example, if you buy something at a certain cost and sell it at a profit, you can express that profit as a percentage of the original cost. Similarly, if there's a loss, you can do the same. This makes it easier to compare different transactions or products, regardless of their actual amounts. In the broader context of our presentation, understanding profit or loss percentages helps us analyze profitability more effectively and make better business decisions. When we borrow money from the bank, we usually have to pay some extra amount called interest. Now, the money we borrow is known as the principal. The interest is essentially the cost of borrowing that money. At the end of the year, we pay back the original amount plus the interest, and this total is called the amount. The key formula to remember here is that the amount equals the principal plus the interest. Keep in mind, the interest itself is calculated based on a few important factors: the rate of interest, the principal amount, and the time period for which we borrow the money. Simple interest is a straightforward way to understand how much extra we owe, and it plays a vital role in many financial transactions. Understanding these concepts helps us make better decisions about borrowing and lending. Now, let's look at how to calculate the simple interest for a period of 3 years. Here, the principal amount P is 200 rupees. To find the simple interest, we use the formula. Simple interest equals P times R times T divided by 100. Plugging in the values, we get 200 times 10 times 3 divided by 100, which equals 60 rupees. So, the interest earned over 3 years is 60 rupees. Next, to find the total amount after 3 years, we add the interest to the principal. That gives us 200 plus 60, which totals 260 rupees. Remember, the rate of interest R is 10%, and the time period is 3 years. This example highlights how simple interest is calculated straightforwardly using the basic formula, and how it accumulates over time. It's a practical way to understand how investments or loans grow over a fixed period.